Indices and Logarithms. Application of common logarithms in numbers less than 1. Logarithms are applied in almost every part of life, directly or indirectly. They help us to simplify work involving numbers. Discover how this is applicable. Expressing numbers as powers of 10. Numbers can be written such that 10 is the base. Power of 10 is called a logarithm. For example, express the following numbers as powers of 10. 1000 is equal to 10 to the power of 3. 100 is equal to 10 to the power of 2. 10 is equal to 10 to the power of 1. 1 is equal to 10 to the power of 0. 0.1 is equal to 1 over 10, which is equal to 10 to the power of negative 1. 0.01 is equal to 1 over 100, which is equal to 1 over 10 to the power of 2, which is equal to 10 to the power of negative 2. 0.001 is equal to 1 over 1000, which is equal to 1 over 10 to the power of 3, which is equal to 10 to the power of negative 3. The powers 3, 2, 1, 0, negative 1, negative 2, and negative 3 of the numbers 1000, 100, 10, 1, 0.1, 0.01, and 0.001 respectively are known as their logarithms. The logarithm of 100 written as log 100 is equal to 2 since 100 is equal to 10 to the power of 2. The logarithm of a number can be read from logarithm table. For example, logarithm of 4.926 is obtained as follows. In the column headed X, read 4.9, then proceed horizontally to the column headed 2, read 0.6920. In the mean difference columns, proceed further horizontally and read 5 in the column headed 6. To get the logarithm, add 5 to 0.6920 as shown below. Therefore, log 4.926 is equal to 0.6925. For example, logarithm of 4.926 is obtained as follows. In the column headed X, read 4.9, then proceed horizontally to the column headed 2, read 0.6920. In the mean difference columns, proceed further horizontally and read 5 in the column headed 6. To get the logarithm, add 5 to 0.6920 as shown below. Therefore, log 4.926 is equal to 0.6925. Example 1. Find log 6.72. Solution. Write the number in standard form, that is 6.72 is equal to 6.72 multiplied by 10 to the power of 0. From the logarithm tables, the log of 6.72 is equal to 0.8274. Example 2. Find log 32.3. Solution. Write 32.3 in standard form. 32.3 is equal to 3.23 multiplied by 10 to the power of 1. Log 32.3 is equal to 1.5092. Note that the logarithm of a number has two parts: the integral part, which is called the characteristic, and the decimal part, which is called the mantissa. Above, 6.72 was written as 6.72 multiplied by 10 to the power of 0. Example 1. Log 6.72 is equal to 0.8274. From the example 2, 32.3 is written as 3.23 multiplied by 10 to the power of 1. Log 32.3 is equal to 1.5092. Note that the power of 10 when a number is written in standard form is the characteristic. Example 3. Find log 0.0079. Solution. Write 0.0079 in standard form. 0.0079 is equal to 7.9 multiplied by 10 to the power of negative 3. In this example, the power of 10 is negative 3. The characteristic is written as 3 with the negative sign on top, that is read as bar 3. Therefore, the logarithm of 0.0079 is equal to bar 3.8976. For numbers that are between 0 and 1, the characteristic is always negative and the mantissa is always positive. Example 4. Evaluate the following using logarithms. 728 multiplied by 32.6. Solution. When multiplying numbers using logarithms, write them in standard form and read the logarithms from the mathematical tables. Arrange them as shown below. The logarithms are added to get 4.3753 from the anti-logarithm tables. In this lesson, you're going to learn about the basic operations on bar numbers, logarithms of numbers between 0 and 1. Logarithm of numbers between 0 and 1 have a negative characteristic, but the mantissa is always positive. For example, log 0.02 is equal to log into bracket 2.0 multiplied by 10 to the power of negative 2, which is equal to bar 2.3010. Such logarithms are known as bar numbers. Bar 2.3010 can be written as negative 2 plus 0.3010. Therefore, bar is simply a minus sign written above 2 as bar 2 and read as bar 2. We are now going to perform basic operations on bar numbers. Addition of bar numbers. Example 1. Evaluate bar 1.1502 plus bar 2.1051. This is rewritten and arranged as negative 1 plus 0.1502 plus negative 2 plus 0.1051, which is equal to negative 3 plus 0.255 3.2553. This gives bar 3.2553. Example 2. Evaluate bar 3.4213 plus bar 1.7055. Solution. Rewrite and arrange as -3 plus 0.4213 plus -1 plus 0.7055. Note that -4 plus 1 is equal to -3, which is equal to -4 plus 1.1268, which is equal to -3 plus 0.1268. This is equal to bar 3.1268. Subtraction of bar numbers. Example 1. Evaluate bar 4.5082 minus bar 2.4701. Written as -4 plus 0.5082 minus -2 plus 0.4701, which is equal to -2 plus 0.0381, which is equal to bar 2.0381. Example 3. Evaluate bar 1.6301 minus bar 3.8015. Solution. -1 plus 0.6301 minus -3 plus 0.8015. It is not possible to subtract 0.8015 from 0.6301. Therefore, we borrow or subtract 1 from -1. Characteristic, that is -1 minus 1, which is equal to -2. And then we proceed as follows. -2 plus 1.6301 minus -3 plus 0.8015 is equal to 1 plus 0.8286. Note that -2 minus -3 is equal to -2 plus 3 is equal to 3 minus 2 is equal to 1. Multiplication of bar numbers. Example 1. Evaluate bar 2.3501 multiplied by 3. Rearrange as -2 plus 0.3501 multiplied by 3, which is equal to -6 plus 1.0503, which is equal to -5 plus 0.0503, which is equal to bar 5.0503. Example 2. Evaluate bar 2.1231 multiplied by -2. Arrange as -2 plus 0.1231 multiplied by -2, which is equal to 4 plus -0.246. Note that in logarithms, the mantissa should be always positive. In case it is negative, it changes to be positive as shown below. Borrow 1 from 4 and then proceed as follows. 3 plus 1 minus 0.2462, this becomes 3 plus 0.7538, which is equal to 3.7538. Division of bar numbers. Example 1. Evaluate bar 2 0.1608 divided by 2. Solution. Rewrite the number as -2 plus 0.1608. Then divide each by 2 as shown below. -2 over 2 multiplied by 0.1608 over 2 is equal to -1 plus 0.0804, which is equal to bar 1.0804. Example 2. Evaluate bar 1.50602 divide by 2. Bar 1.50602 is equal to -1 over 2 plus 0.5060 over 2. The characteristic should be a whole number that is divisible by 2. We think of a possible way of making it divisible by 2. For example, subtract 1 from the characteristic -1 and add 1 to the mantissa. That is, -1 minus 1 is equal to -2, and 1 plus 0.560 is equal to 1.5060. This gives -2 plus 1.5060. Divide -2 plus 1.5060 by 2 as follows. Computation using logarithms. Example 1. Work out 0.0256 multiplied by 0.5792. Solution. Arrange the working as shown below. Find antilog of bar 2.1711 is equal to 1.4829 multiplied by 10 to the power of -2 is equal to 0.01429. Example 2. Evaluate using logarithms. Cube root of 0.1448. Solution. Bar 1.1898 over 3 is written as -1 over 3 plus 0.1898 over 3. Borrow 2 from -1 to make the characteristic divisible by 3 and add 2 to the mantissa 0.1898. -1 minus 2 over 3 plus 2.1898 over 3 is equal to -3 over 3 plus 2.1898 over 3, which is equal to -1 plus 0.7299, which is equal to bar 1.7299. Find the antilog of bar 1.7299, which is equal to 5.3691 to the power of -1, which is equal to 0.53691. Example 3. 0.326 to the power of 3 multiplied by 42.27. Solution. Number 0.3263. Standard form. 3.26 multiplied by 10 to the power of -1. Log. Bar 1.5131 multiplied by 3.